has mass and occupies space. Okay, toss that gently to somebody. And this is where nobody will look at you.
All right, go back.
Okay, watch it out. Yeah, somebody catch it. Okay. Now, tell us what energy is.
Oh, the capacity to do work.
Exactly, like bending over to pick that thing up or throwing that. That's energy, capacity for doing work. And anything you think of in the universe, you should be able to classify as matter or energy. Now, what I've added up here for our other two definitions, I said it, but I didn't write it on Tuesday. In real life, everything's happening at once, but our brains are limited. We can't study everything at once. And in fact, in schools now in Texas, in 9th grade or 8th grade, they teach IPC, I think, Integrated Physics and Chemistry. I think they're doing away with that course because you try to study both in 1 year, especially if you're 8th or 9th grade. So I think, I've heard rumors they're phasing that out, and I'm not sure what's going to replace it. So chemistry, study of matter and the changes that matter undergoes. So the part of the universe that we chose to study is the matter part of it. But if you're down the hall in a physics class, you're studying the rest of the universe. But you're studying energy and the changes that it undergoes. Now, in actual fact, of course, like I mentioned, I think on Tuesday, if you burn something, okay, we as chemists would be interested. What is it we're burning? Is it propane? Is it natural gas? What is it we're burning? Also, how much oxygen does it take? We talk about the stuff. If you're in the physics department, you would say, okay, if I've got 10 grams of butane or propane or some gas, and I burn it, how much heat do we get off? And then, if you want to take that one step further, okay, chemists talk about the stuff, physicists talk about the energy and how much energy, but the engineers, they go, what can we do with that energy? And so the engineers say, let's take that heat. And this would be years ago, because engineers, what is an engineer? They solve new problems, as opposed to being a technologist. In technology, you solve old problems. Got a computer that's not working? Somebody that's a technician fixes the computer. That's an old problem. They know about computers. The guy that first designed computers would have been an engineer. So engineers solve new problems. So that heat, years ago, they'd say, what can we do with that heat? Okay, we can use that heat to boil some water, make some steam, have the steam, turn a wheel. The wheel then is going to generate some electricity, and we can go use that electricity for this, that, or whatever. So the engineers are always the practical ones. They say, what can we do with this? What new? What can we solve? What kind of problem can we solve? Okay, so that is section 1. Those are the things. Now, yeah, I know there's some more stuff in there about conservation of energy. You can't create nor destroy energy. You can just change forms. It's conservation of matter. But as we get to problems that have to do with conservation, we'll talk more about that. Okay, now let's get into section 2, and we got a whole bunch of stuff here. So section 2, let's get our first definition. But what I'd like to do is jump just a little bit ahead in the book. And they use a diagram, and it's in my Blackboard site too. It's a couple of sections on it. Of course, here in chemistry, we are studying matter. Well, matter, we have a subdivision. We can talk about pure substances. Now, we in chemistry use the term for pure substances different than somebody in nutrition would. In nutrition, they'd say something about a pure substance, meaning there's not microorganisms. You know, this food is pure or whatever. They use it slightly differently than we do. When we talk about pure substances, there are 2 types for us: elements and compounds. Okay, and what that means, if you've got an element, say gold. Gold has the same properties. It doesn't matter if it's a hunk of pure gold here in Houston or gold from South Africa or West Africa or wherever. Gold is gold. So if it's the same, wherever you find it, then it's a pure substance. And there's the two types, elements and compounds. And then over here, mixtures. And mixtures come a little bit later in the chapter. But let's take a look at elements. Our first definition here. We have approximately 100, and these are the basic building blocks. 100 basic building blocks. And of course, we have a periodic table up here. And if you look at this periodic table, it's blank by number 104. Take a look. If you've got your book with you, look right inside the front of the book. Right inside the front of the book there. A periodic table. How many elements do you see listed there? How many do you see? Okay. Look, then it continues up into here. What's the highest number you see there? 118? Okay, so what that means is this is really old, but it doesn't really matter because those things that are way down at the end, usually they're synthetic, they're made in the laboratory. Sometimes they just have a life of a few seconds. They're so rare, we're not going to be working with them in the lab. And so our old periodic table is going to be just fine. Now, every element, of course, has a name. It also has an abbreviation or a symbol. And they've used several different things here. Of course, sometimes they just use the first letter of the word. Okay, so if you have C, that stands for what? Carbon. Well, there's only 26 letters in the English alphabet, so once you use the C for carbon, you're out of luck. And so what they do sometimes is to use the first two letters of the word. Okay, so if we have some Ca, calcium. You talk about little kids should drink their milk to get calcium for strong bones and teeth. Old folks, well, middle-aged and older, need to take calcium supplements for strong bones so they don't have osteoporosis. So the first two letters. Now notice the way they do it. And this is like grammar in an English class. If there are two letters, the first is always capitalized, the second is never capitalized. So you need to write them that way. There's some good reasons for it. Another C one. If I have CO, what have I got? What? I've heard two different answers here. Which is it? Cobalt. Cobalt. First two letters. Cobalt. Okay, so capital C and small o. And if it's just one letter, it's always capitalized. Okay, so we have cobalt. If you took a multivitamin this morning, if there was vitamin B12 in that vitamin, then you took in a little cobalt, because right in the center of that molecule of vitamin B12 is cobalt. So we need trace amounts of it to stay healthy. So cobalt is here. But somebody said copper before. What is the symbol for copper?
Cu.
Cu. Now, why are they using Cu when in English we spell copper C-O-P-P-E-R? What have they done? They've gone to the Latin. So if it seems really weird, it's probably the Latin for it. Now let's look at, I can think offhand of about 3 cases where there is confusion, so let's just run through them to be sure everybody's got it straight. Okay, if I have S, what do I have? Sulfur. What do we do for sodium?
Na.
Na, excellent. Natrium, we go to the Latin. Those two are confusing. S for sulfur, but Na for sodium. Okay, another set of confusion. Okay, I stands for iodine. Iodine. But what do we do for iron? I heard some of you answer iron. Fe. And where did it go? Right here. Fe. Because we've gone to ferrum, the Latin. Okay, Fe and I. Easy to confuse. And then, let's see, the other easy to confuse. If I've got P, I've got phosphorus. Phosphorus, good. But what do I do then for potassium? K. Okay, so those two are easy to confuse. So be sure, there is a table, and it's on page 18, whether you have the 8th edition or the 9th edition. and it is not table 1-4, but table 1-3. Those are the need to know. So be able to recognize the symbol, and it's this part right over here. This is the textbook, page 18. So if you want to mark that, table 1-3 is the important one. 1-4 is just simply abundance in the earth. So that we're not going to worry with, but that top one we will. Okay, now I want to show you why we got to be so careful. Because what if you wrote down capital C and capital O side by side? The C would stand for capital C, carbon, and the capital O would stand for oxygen. If you have capital C, capital O, you've got yourself carbon monoxide, toxic gas. Whereas, if you write it capital C, small o, you've got cobalt, something good for you in trace amounts. Okay? All right, so be sure that you know some of the symbols, and I have some samples, because we don't get to see elements that often. I'll pass them around. They're in plastic test tubes, so hopefully we won't drop and break anything. Okay, if I have, let me do the easy ones first. I've got S. What have I got there? Sulfur. And you can buy this in a pharmacy. They say it's really good for chiggers if you're camping or hunting. I won't say hunting, camping. If you're outside in the woods, put it around your socks, your boots, and supposedly chiggers won't get to you with that. Now let's see, that's sulfur. All right, nickel. What's the symbol? Ni. Okay, and nickel's a metal. Here we have it in powder form. Okay, a tough one. I've got tin. I've got tin. What's the symbol?
Zn.
Not Zn, that's zinc. Sn. Good. Oh, are you cheating and
Yeah.
looking at it? I saw your eyes go that way. Yeah, tin is Sn because we've gone to the Latin. You know the toothpaste? They say buy our toothpaste. It's got stannous fluoride. Why do the advertising people say that? Because tin fluoride sounds cheap. You know, it sounds like a little tin can. Tin fluoride? No, they don't say that. They say buy our toothpaste. It's got stannous fluoride. Makes it sound exotic, and they can charge you more. And so this is what tin metal would look like. Okay, a really tough one. Cadmium, a toxic metal found in cigarette smoke. CD, excellent, excellent. A heavy metal. Okay, here's an interesting one. Little rockets here. Si, do you know what that is? Silicon. Silicon. Now, there's so much controversy, or there was, I think it's kind of settled now, but breast implants are made, they can say silicone breast implants. Well, it's not, obviously, they're not sticking this junk here. It's a compound of this. I think an oxygen silicon compound that's kind of a jelly-like stuff that's kind of flesh-like. So there was a lot of controversy a few years back. My sister, being a pathologist, used to get stories about this, that people would think they were getting really sick because the silicon leaked into their body and thought it was making them sick. And so the person would go in and have the implants taken out. They had to be sent straight to pathology and be weighed. Okay, because they had the weight of them before they were put in, the weight of them when they came out, to try to show they weren't leaking, that it was the same weight. And the surgeons used to just yell at the pathologist, weigh it again, because they didn't want to see a loss, because there could be lawsuits involved there. So anyway, it's a compound of this stuff. And by the way, it's not implants just for women. I'll let you think where else they might go. Dogs, show dogs can get implants, okay, small, medium, and large, because a show dog, a male show dog, I understand, cannot be neutered, okay, but they try to fake it, because if you don't neuter the dog, it's usually more aggressive. So they want them to show and be docile, so they neuter them, and then they can fake it. Okay, my dog said he'd take large, please. No. But anyway, they use the same stuff, and they also use saline.